Hi everyone, my name is Melanie Boncillon, and today I'll be talking about how visualizations can elicit different decisions in a risk-prone lottery game. First, a little background. Researchers in various fields have used different methods to evaluate how visualization impacts risk perception and decision making. In the medical field, people have used hypothetical scenarios to measure how visualization impacts risk behavior. For example, in the study by Galezic et al., participants were asked to rate the seriousness of the disease as well as the helpfulness of screening on a Likert scale. In the visualization field, researchers have measured different decisions made from visualizations using simulations. For example, how to best grow and sell crops given weather information, or when to leave your house to catch the bus on time while minimizing waiting time. Although prior work has examined how visualization impacts decision making, a lot still remains unknown. This is likely because the decisions used in prior studies are all different and there is no concrete method for quantifying and comparing the impact of different encodings. However, other research communities, such as economics and psychology, have been measuring decision making for decades. In this paper, we leverage work from economic theory to design an online lottery game to evaluate the impact of visualization on risk behavior and gambling decisions. Consider the following question and think of which option you would prefer. Option A, 50% chance to win $1,000 or a 50% chance to win nothing. Option B, $450 for sure. Now, most people would choose the sure amount, but the rational choice is option A. Let's find out why. One of the dominant theories of decision making, expected utility theory, has served for many years as an economic behavior model and a model of rational choice. It states that people make choices based on their utility, the psychological values of the outcomes. Option A has a higher expected value and is therefore the best option to maximize potential gains according to EUT. But we know that most people don't choose a rational choice. Prospect theory was introduced as an alternative to explain and model people's biased behavior. It states that people tend to underweight common or high frequency events while overweighting rare or low frequency events. We use economic theory to evaluate the impact of 5 different visualizations on risk behavior and decision making. Pie and circle charts are common in information graphics and market surveys. The triangle, circle, and bar charts are all used in the medical community. We use a lottery decision sheet where participants chose 7 probability values and rewards range from 10 to 150 points. Here's an example of a lottery sheet. People were asked to decide between receiving sure gains and entering the lottery. Here, the participant has a 25% chance to win 20 points and a 75% chance to win nothing. They chose to settle for a minimum of 15 points as a sure gain, then decided to enter the lottery. We run a function that picks a random row on the lottery sheet. If the participant selected sure gains for that row, the corresponding value is added to their bonus, where 1 point represents $0.001. If the participant chose to enter the lottery for that row, we run a lottery simulation based on the probabilities to determine if the participant wins the full amount or wins nothing. Each participant completed 25 lottery sheets and could win a total bonus of up to about $10. We measure their attitude to risk, ranging from risk-averse to risk-seeking using a measure called relative risk premia, or RRP. An RRP of 0 represents risk neutrality. Negative RRP values indicate risk-taking behavior, and positive values indicate risk aversion. The certainty equivalent is the value at which the participant chooses to enter the lottery. The expected value, like we saw earlier, is the value at which the gains are maximized. We will now look at the results. Let's look at the first box plot of this series. Here we have the RRP results for the icon group. On the x-axis, we have our probability values, and on the y-axis, the RRP values. Recall that lower values for RRP means risk-seeking, and higher values for RRP means risk-averse. We can see that for the icon array, people were risk-seeking for smaller probabilities and risk-averse for large probabilities. This is exactly what we expect to see, as it is in line with prospect theory. Looking at the other conditions, we observe a similar pattern. Now, when comparing RRPs across conditions, we can see that icon arrays have a median RRP of 0, representing risk neutrality. The circle and triangle conditions appear to incite the most risk-seeking behavior. We ran separate Wilcoxon Mann-Whitney tests across all pairs of visualizations for all probability values to check our preliminary findings. The results partially confirm that icon arrays led to more risk-averse behavior compared to the text condition. We found that risk behavior for participants in the circle and triangle groups deviated significantly from the non-group overall, providing evidence that participants who saw the triangle design were the most likely to gamble, followed by the circle design. Notice that the bar condition shows no significant difference to the text condition across all probability values. Let's summarize our findings. We found that visualization impacts decision making. Economic theory is a sound method for quantifying and evaluating decision making with visualization. Circle and triangle designs elicit risk-seeking behavior. People are most risk neutral with icon arrays. Finally, across all probability values, there was no significant difference between the bar and the text condition. So which visualization is best, icon or bar? On the one hand, according to economic theory, the best decision is the one that maximizes expected utility, the risk-neutral decision. On the other hand, we have seen that in real life, people don't make decisions rationally. Our control condition, text, represents expected behavior. It is important to have a better understanding of how people make different types of decisions. Opening the discussion to what constitutes sound decision making will allow us to better understand how visualization impacts decisions.